Systems of inequalities where one inequality is quadratic and the other is linear. When solving systems of inequalities where not all are linear, for example, when one inequality is quadratic, we use the same approach as in systems of linear inequalities. The only difference is that one of the lines is a parabola, so the solution zone has one curved side. Another thing to point out in such systems is that if we are interested to find any minimum or maximum point as in the previous examples, we must solve the corresponding system of equations only by substitution method. Thus, one of the variables in the linear equation is expressed in terms of the other variable and we substitute it in the quadratic equation. Let's consider an example to clarify this point, where theory and exercise are combined to have a better understanding. Example: solve the following system of inequalities. We have the following shown on screen. Solution. First, we identify the direction of the solution set for the linear inequality. We do this by writing the first inequality in the form y m x plus n. Thus, we have the following shown on screen. Hence, the solution zone of this inequality alone lies under the graph's line y equals 3x over 2 minus 1 over 2. On the other hand, the quadratic equation is already in its regular form y a x squared plus bx plus c, where a equals 1, b equals minus 2 and c equals 1, while the inequality symbol which replaces the question mark is greater than or equal to. This means the solution zone lies above the parabola's graph. The best thing to do is to solve the system of the corresponding equations. The number of solutions depends on the sign of the discriminant obtained when the linear equation is substituted into the quadratic one. In the specific case, we have the following shown on screen. We can write 3x minus 1 equals 2y, multiply the quadratic equation by 2 and then express y in the quadratic equation in terms of x. In this way, we have the following shown on screen. This is a second-order equation with one variable, where its roots represent the intercept of the two original graphs. We have a equals 2, b equals minus 7 and c equals 3. Thus, the discriminant, we have the following shown on screen. Since the discriminant is positive, we have two intercepts for our graphs. Their x-coordinates are found by solving the second-order equation above. Expressing the two intercepts by a and b, respectively yields, we have the following shown on screen. We have the following shown on screen. The corresponding y values for points a and b are shown in the following shown on screen. Hence, the two intercepts are a, 0.5, 2.25, and b, 3, 4. Another important point of the solution set that helps identify, in this case, the lowest point of the solution set is the parabola vertex. We have briefly discussed this point in previous tutorials, where the formulas used to find the vertex v of a parabola are shown in the following shown on screen. Substituting the known values for the original quadratic equation, a equals 1, b equals minus 2 and c equals 1, yields we have the following shown on screen. We have the following shown on screen. Hence, point v, 1, 0, is the vertex of the parabola, which at the same time acts as the lowest point of the solution set for the original system of inequalities. The graph solution for the system is shown in the following shown on screen. We can draw the following conclusions by looking at the graph. 1. Vertex v is the minimum point of the system solution set. 2. Point A is the leftmost point of the solution set, but point A itself is not included in this set. 3. Point B is both the maximum and the rightmost value of the solution set, where it is also excluded from the solution values. 4. The two intercepts A and B can be used to plot the linear graph, since plotting the graph of a straight line requires only two known points. We can use the same approach for systems with more than two inequalities, where not all of them are linear. That is all for lesson 10.4.4 and the end of chapter 10. To continue this mathematics topic, please watch 11.1 Introduction to the Definition of Monomials and Polynomials. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.